Hello students, this is Dr. Diaz and I'm here today to talk a little bit about Regio Selectivity and stereoselectivity because I was grading your classwork 13 and I saw the many mistakes on this problem that I had a molecule of iodine over there, and I feel that we need to do a little bit more work, a little bit more on this. So, and there, the molecule that I'm going to use here will be different because I want you to learn. So I'm gonna use this, but I wanna just focus on everything that I'm gonna show you Regio selectivity and also stereoselectivity. So we know this E1, so elimination 1, what happened, the bromine will leave with the electrons forming, and this way a positive charge over here, because he just carried the electrons. So, and I have my molecule over here. I will give emphasis on my hydrogens that I have around over here, and the carbon, adjacent carbons must be adjacent carbon. This is my alpha carbon, so must be always in the beta carbons. So beta carbon will be the adjacent of or neighbor of the alpha carbon. So I have some hydrogens that the water can attack. So I have a hydrogen over here, and I can use another color to the other hydrogen. I can have one hydrogen over here. Oh, sorry, not this one. So this is the carbon adjacent over here. So we have this over here, hydrogen. So because we have a 1, 2, 3, and the other bond is with hydrogen. Carbon is tetravalent, so it's 4 bonds, right? So I will attack first this first hydrogen over here. And what's gonna happen is the water gonna come here and will grab this hydrogen over here, and the hydrogen will leave behind the electrons. Its electron, and these electrons here will form a double bond. So we're gonna have here our new structure now with a double bond. If I tack this over here, also I can form a double bond over here, right? So I will attack, let's see, this over here. So the next one I'm gonna do is this. So I'm gonna have my charges over here. The hydrogen that I was working with is over here, right? So the water is gonna come here and will grab this. Oh, I completely forgot the H3O, which is the conjugate acid. Don't forget that. So as soon as this catches by the water, so we'll leave here the electron forming a bond. So I'm gonna have this over here. Right? So I have one over here that if you do this, we're gonna have 2, and we're gonna have 2, and we're gonna have like this. So don't forget the hydrogens. I will not put all here. And here, what I see here is one methyl group over here, and the hydrogen over here, 1, 2, 3, 4. And here I have a methyl group over here, and here I have this, right? CH3. So what happened here is this one over here, I have more substitutions here. So 1, 2, 3, 4. That's tetra substituted, right? Tetra substituted. This is Zaitsev, right? And here I have, let's change the color over here. So I have 1, 2, 3. So this is the tri-substitute. We can call here Hoffman. Since it is N1, this is the major, okay? So now let's see one thing. This we can call Regio Selective. Okay, we choose the hydrogen and we can use the hydrogen on different carbon, adjacent carbons over here. And if you talk about Regio Selective, right? So Regio Selective is the one. So Regio Selective will be about cis and trans, or E and Z, Z and E. We can use cis and trans if you have identical substitutes. Here we have 1, 2, 3, 4. I'm looking to this one, which is the major product, it's XF. So I could have this over here. So I have CH3 here, and we have an ethyl group here, and here I have a methyl group, and here we have an ethyl group, right? So remember how we check about E and Z. So we have 4 difference over here, right? Or 2 equals and the 2 equals. So we have here in this side, let's go and look to this carbon over here. In this side, I have 1 methyl group and 1 ethyl group. So this one is the priority over here. So if I look to my other carbon over here, I have methyl group and ethyl group. This is my priority over here. So we are in the position, if you trace a line, you're going to see that we both major groups or priority group are in the same side. So Z, same side, so it's cis. This is less stable. So the molecule will be more time in this position over here. So we're gonna have the methyl group over here, and the methyl will be here, and we're gonna have our other big group over here, ethyl, priority, that is our trans over here, right? So this is E. So this is what we call Regio Selective. This is the where the structure, the molecule will be more time because it's more stable. And actually, if you see here the graphic, so in the energy, so we're gonna have like trans like this, and probably here will be the cis. So we have more energy here in this point of the transition. Okay, here it says in trans. So that's it. That's all. Bye.